digital twins for infrastructures and cities. So today we have the pleasure of hosting Onur, who is associate professor at Istanbul Technical University in the civil engineering department. And so Onur is an expert in infrastructure asset management with digital twins and AI technology. So we'll present some of his work on designing resilient and smarter cities. So Onur was also teaching last year in the master program. So it's great to have him this year to deliver this conference. So thank you again, Onur, for your time, and the floor is yours.
Thank you very much. Appreciate it. It's always a great pleasure with the friends. And I'm so happy to be here. Today, in the next 45 minutes, I will talk about my understanding of digital twins and how it is going to help transforming infrastructure for more resilient cities. And I think this subject is as you are going to see as we work through it, it's going to be very interesting. And I think it's a great pleasure to be part of this master's program. And I will emphasize my points throughout my slides. So let me talk about myself a little bit. As the professor mentioned, I'm a civil engineer, and I'm proud to be a civil engineer. And I think civil engineering, especially these days, is becoming much more important, and many people doesn't understand it. And I'll explain that throughout my slides too. I was lucky enough to study artificial intelligence applications since my master's years. I did my master's and PhD in Chicago, and around 97 I got my PhD. And I always tell my students also, my subject of my master thesis in 97 was using AI to predict the outcome of construction litigation. So I want you just to have the perspective that we are dealing with AI in civil engineering around 30 years ago. So that is, I think, and I think around 98 and 98, 99, we have our first publications in AI. So AI is not new for civil engineering, and we utilize AI many times. And I was lucky enough to be part of Istanbul Technical University in the last several years. And I'm also be part of the team at the digital group. So I'm really enjoying, and hopefully I will be able to tell you what we are doing for the last couple of years. So I think the first thing that I want to mention is why infrastructure is a challenge. What is really happening? And not many people really understands that the infrastructure that we have is literally getting old, and it is time that many of these things has to be replaced. I always give the example from United States. I don't know what Trump administration will do, but Biden administration was planning to spend around $2 trillion, and you didn't hear wrong, $2 trillion for the infrastructure, because their infrastructure is getting old. And as I was looking for the information, I just wonder how old the infrastructure is. So from New York Times, I got this little graph saying that actually many of the things are quite older, 20 years old, but many of their bridges, roads, airports are actually much more than that. So there is this challenge that we have the infrastructure is getting old. And this is true for the Europe too. Many of the infrastructure, yes, Europe is ahead of the many of the other parts of the world, but they built these things long time ago, and these infrastructure is getting old from every perspective. Railroads, highways, roads, tunnels, airports, ports, these are getting old. So there is this huge reason, huge problem that we have to be able to proactively take a look at what is really happening. And the other problem is, and this is the problem of the many countries, we have inefficient operations, and there are many reasons for it. And we can go to root cause of the problems, but involvement of the human and with the government mentality, and many of these infrastructures, as you know, owned by the government, roads, highways, etc. So with the mentality of the government, it is becoming really difficult to manage and operate. And my professor was saying about the asset management. It's becoming difficult to manage the assets because there are, as I said, first, this is getting really old. Second, with the government mentality and with all these old infrastructure, when they are combined, and people are expecting services, it is becoming this very complicated problem to solve. And top of it, unfortunately, we have two new things joined to us. One of them is the natural disasters. Yes, we did it for a long time, but now we know that actually with the efficient solutions, things like digital twins, which I will be telling in a second, we can literally help tremendously because even in Turkey, which I have a special slide for it too, I will explain in detail. One of the things we learned through the Kahramanmaraş earthquake, which is literally a year ago, that actually the earthquakes are there and we cannot forget about them. And when they hit, everybody complains about the services that they take and the response time, etc., which actually tells us that there has to be a better solution for these natural disasters. And recently we had the floods for example, in Valencia. We are seeing that actually there is a need for a better system, and the lack of this system is literally hurting us. So there is a need for a system. And the other thing that this is the new subject, cyber threats. If you ask me 20 years ago, nobody worried about these things, but now with the information, and as many of you are the students in our program, you already learned that what digital twins depends on the data and collecting the data. And if you don't protect this data, that there will be cyber security attacks, which is also incredibly bad. And we learned that very badly during the earthquakes, because during the earthquakes, one of the first things that we noticed, there are some bad people producing bad false information through social media, etc., which is actually adding top of everything else. Say you are trying to rescue people, but at the same time, instead of people helping to the rescue, they are complaining about other things, which is creating a chaos. So therefore, one of the first things that we learned through these things, that yes, we need the digital twins, yes, we need these super systems that collects data so that we can manage them. But we also understood that the cybersecurity is a really important thing that we really learn. And as we are talking about these things, what is digital twin? And that is always the question. And the best part of it, you are not the only one, because you always question, probably as a student or a professional, what the heck is this digital twin? And that was actually one of the things we were also questioning. Therefore, a bunch of professors, including Professor Matthew and Professor Marcos, etc., we came together. We looked at the definition of digital twin, and this was just recently published. And that's the reason I tried to put the link there. You should definitely take a look at it. So what I'm saying is we are also in the process of defining what is digital twin. But as our understanding is, it's basically a real-time dynamic virtual replica of a physical system. So we have a physical system and we have a virtual system. And basically with the help of IoT sensors, AI, simulation capabilities, and basically adding predictive maintenance into this, we are trying to create systems that are better manageable and the assets are better managed. And I want you to also understand, when we talk about the assets also, it's such a deep meaning to it. So we have these tangible assets, and if you look from the government perspective, every single bridge that you are responsible of maintaining, every single tunnel that we are responsible of maintaining, including every single thing, railways, etc., that are owned by the government or for the companies, agencies. We have to be able to manage these assets. And then top of it, I want you to also understand that we have the other things in the asset management, such as the electronic equipment, etc. So the concept of assets, when we talk about digital twins, is such a large subject that we have to really worry about. So these has to be defined properly, and the definition of digital twin has to be defined properly so that we can just manage these things properly. And I want you to add at this moment, we talked about Industry 4.0 revolution. And then now we are talking about Industry 5.0 revolution, where we talk about the robotics and the human robot interaction. And we are looking for such an areas that sometimes makes us think that as we are talking about these different things, as we are thinking about how we are gonna approach all these subjects, but when we look at the root cause and root reasons for these developments, we are seeing that actually there is a need, and there is a tremendous need for a different type of education. Okay, and this is actually a great burden on the professors on the undergraduate level, because it's not easy to change the undergraduate curriculum to prepare our students for this new upcoming world. But actually, it was great for the master's program, because when we look at this master's program was very well defined. And, it was basically, we tried to answer every single thing that I mentioned to you in a way that through the courses and through the conferences, through the industrial processes such as capstone projects, we try to answer these things. But still, there is a need for a new type of positions and with new type of education to create this group of people who can answer these problems. So I want you to understand that this is an important problem, because the students that are coming from regular curriculums in Europe, in Turkey, in Middle East, in United States, they are not necessarily ready for this revolution. And I want you to emphasize this very strongly. This revolution requires different type of thinking. Not only people who understands good structural engineering, not only people who understands good geotechnical engineering, but they are ready for also the digital environment, AI and data science, analytics, predictive maintenance. These concepts are such important concepts. So, and I will definitely suggest that if you have time, please go ahead and read that article. As we are going through this thing, and one of the things that I always tell myself, so how this started and how it is moving away. So maybe it was 1990s, in the beginning of 1990s, we start to use computer-aided design, and many of you already uses Autodesk programs such as CAD, AutoCAD, etc. And then we had the BIM revolution, which was maybe 20, 25 years ago, and now we learned that and Europe, United Kingdom, and United States really understood the value of three-dimensional thinking, and they really understood that without having three-dimensional components into design, it's not going to be very interesting, or it's not going to be that easy to build the buildings properly, even though CAD worked properly. But what I'm saying, that we needed these database concepts and information concepts early enough that was going to prepare us to today. And actually, we couldn't explain that 20 years ago. We were telling this thing, but nobody was understanding the vision, what is really going to happen 20 years later. But that was the beginning. We started with the BIM and CAD, and then we start to introduce things like GIS integration and IoTs. And then with the introduction of using AI, much more common, because as I said, we were using AI 30 years ago. But in one of my recent research papers, we looked at the evolution of AI predictive studies, and there is a huge jump in 2017. So you can take a look at it and see it. 2017 to 2025, things basically exploded. Everybody started to work on AI. And especially, and I would like to emphasize on it, and I can't tell you how important it is to get education, not AI only, but an education like we have in this program. After the pandemics, one of the first things we learned through the pandemics that, the digital revolution, actually, maybe not even revolution, digital transformation is something that you cannot escape. You have to have that. And this is in every research or every seminar we explained, we prepared in the last 20 years. We always said that infrastructure management, civil engineering, architectural management, we are always behind the curve comparison to the industry because we were always conservative and we were always behind the technology. But with the pandemics after 2021, that revolution, that transition happened very quickly because many of the companies were ready for it and they took the advantage of staying home and they start to adapt these technologies. So therefore, starting from 2022, these number of papers, number of the applications increased incredibly. And this also lead itself to the cyber physical systems, basically self-optimizing interconnected infrastructure models. And what start to happen is many cities who actually see that this is coming 20 years ago, who had the foundation to apply these things, they start to apply many of the things that we are mentioning into their cities. And Singapore is a very good example. Like I will definitely suggest that you should search what Singapore did whenever you have time. And also there is a website link. They have several different websites, but this one specifically just ranks the cities. So like you mentioned, let's say Matthew just wonders where does Paris in this list. He can take a look at it and he sees for example, this morning I look at Abu Dhabi, they are 10th. It was a surprise. I would assume that they are much better in the list. But what I'm saying is this is coming, and many of the cities wants to have these things because I want you to understand, old government thinking doesn't work anymore. People demand service. People wants the best of the best. But with the existing structure, it is impossible to serve them. Okay? Because existing structure and existing government thinking doesn't work anymore. And this is not a surprise. This is happening in the United States. If you listen to Elon Musk, they talk about always government efficiency. Many people doesn't like the idea. It is a scary thought. But what I'm saying, this is coming. And this is happening very quickly. So I want you to understand, and this is a beautiful part. Many years being a civil engineer we were always on the conservative side, but we have to lead this thing because the infrastructure doesn't work without architects and civil engineers. When you look at the infrastructure level, we need a new group of civil engineers that are ready for this revolution or transformation, you may want to say, because the cities are demanding this, and without this, it won't work. I'm telling you, this will, if the cities doesn't adapt to this very quickly, it will create different type of problems and you're going to start noticing them because people wants to have the service. People wants to get the better things in their lives. They want to make sure that the metro lines works properly. They want to make sure that the escalators work properly. They want to make sure that they control the comfort in their homes. They want to make sure that if there's snow, the snow is cleaned on a timely manner. So the governments cities, the municipalities have to adapt to these things very quickly, and which requires people like yourself who can look at things in a different perspective and understand these technologies. And I want you to understand digital twins for infrastructure. And I would like to also just to give a quick note. In my presentation, I always say architects and civil engineers. Of course, it will require mechanical, electrical, etc. But when look at from the construction perspective, when we look at anything vertical, such as the buildings, we need to have the architects. So when we come to the city level, we need the urban planners, we need the architects. When we look at the infrastructure level, in many cases, we need the civil engineers, mechanical engineers, electrical engineers. So I want you to also mention that this wouldn't work without the mechanical and electrical engineers. And we need a new group of people who can work in collaboration. Because if we are going to make the cities smart, these are all required components throughout the system. So we have to worry about the physical assets, as I was saying, the roads, bridges. And this is when I was in Chicago, and I worked in Chicago over 15 years as a professional engineer in Illinois. In Illinois, for example, they have a structured information system, which is called SIMS, Structured Information Management Systems. And they have Illinois Structured Information System that works with it. I want you to understand this. They have anything longer than 20 feet. They keep the information in database, so they know exact location of that bridge or culvert. They know all the maintenance requirements, how often they are going to be done, etc. And they keep all the pictures about these bridges, and they keep the pictures about all the structured components of these structures in a database. And this is not new. They are doing this through 1990s, 1980s even. Okay, so I want you to understand, because physical assets are expensive. You cannot, replace the bridges randomly. Like it takes, you have to keep them 50, 60 years and you have to maintain them. So it's a big, it's a big thing to capture all these things and keep in a database. And there are many countries, unfortunately enough, they don't keep they don't keep their structures properly. So with the introduction of GIS many years ago, many cities start to adapt that. But this is something that now with the IoTs and everything, we have fragmented stuff. What is fragmentation? I mean, like whenever I talk about these things to the cities, the municipalities, they say, "Oh, we do have them." And then I listen to them and listen what they have. Yeah, they have, for example, structural health monitoring system for a specific bridge, which is fine. But that is not integrated. I mean, it is just one single structure or two structures, and data goes to different places. But they don't have a centralized system that captures everything, and which has a system that collects this information and do some analytical research by itself, not via some consultant who comes there and do these things. So there is a missing component here in the city level that not many cities really understand that, and which I can understand, by the way, because we have the economic problems throughout Europe, United States, and the Middle East with different kinds of problems, wars, etc. So maybe this is not the first priority right now, but if you don't take care of these things right this moment, the future is going to be much more worse. So there has to be a systematical thinking in the background. So I want you to understand. So we have to take care of the physical assets, which requires many different things, from your clean water to your sewage water to your grids, the electrical lines, etc. This has to be kept in centralized systems that is real time. This data is protected against cybersecurity, and there are systems in the background that can predict what is really happening with the system. So if there's anything going wrong with the system, you can just proactively solve this problem before the problem starts. So because after the fact, the things are going to get really bad, because every single time, and this is one of the things we always say, stupidity is something that you repeat the same thing without changing anything and expecting different results. Oh, it will not change. We have to bring this new type of thinking. And I will, maybe as I keep repeating myself like a parrot, but I want you to understand, programs like these are very important, because this programs teaches people different way of thinking. And this different way of thinking is going to save Europe and the rest of the world, because we need to have these systems in place properly. And unfortunately, when you come my side of the world, and the stupidity that I mentioned, not changing nothing and then expecting different results, we keep living through that horror all the time. We had the earthquake, a bad earthquake in 99 in Kocaeli region, and it was very bad. We helped each other. The Spanish government helped us, French government helped us, all the countries, all the world helped us. And we were very worried. We helped ourselves. We talked about changing these things. And 20 some years passed, and then we have the Marash earthquakes and Hatay earthquake, which are over 7.57 to 7.67 even in the Richter scale, which are incredibly bad earthquakes. And we noticed that actually we did change nothing. Nothing changed. So and this is scientifically, I'm looking from the academician's perspective. I'm questioning ourselves, like, what are we doing wrong? Because, and in Valencia we saw the same thing. there was a flood, there was lots of rain, and then the flood killed many people. So and this is something we can really change, different way of change, different way of thinking. And I think different way of thinking starts with questioning, and different way of thinking happens with adaptation of the technology. And of course, some countries are poorer than the rest, so you don't have money to change things dramatically, but at least you can change the way of thinking. And there is always a story which is very difficult to translate, but there was a big fire and they saw an ant carrying a little bubble of water, and they asked the ant, what are you doing? Ant said, at least I will show that I'm trying to work to stop the fire with the little power that I have. So I think this is also important. Digital twins are creating, it will help us to create better resilient systems. One of the biggest problems we learned through the earthquakes in Turkey, as soon as the earthquake hits, the communication system stops. Do you know the reason for it? Because unfortunately, cell towers are on the top of the buildings, and the buildings collapses, the communication system collapses at the same time. This is ridiculous, right? So resilient structures, resilient systems requires specifically designed towers that are not going to collapse during the earthquake. Not only that, if we have the digital twin of these systems providing information to our center, and hopefully you are smart enough to build your buildings that you are going to capture your data center are not going to collapse, then you can have all types of emergency help and requirements through these systems. But this will require people who can think differently. And then that is also an important point that I have to tell you, that you have to have a way of understanding this. We are, as the professors, we know the fact, but sometimes we live through our old experiences and traumas that we cannot change the system, but you could. So you need to adapt to these new technologies, help us transform this world through these disasters. This is one disaster, but we have, for example, right this moment in the Greek islands, we have volcano problem, and every day there are little earthquakes from Richter scale of 4 to 6, and we don't even know what's going to happen. So this requires different way of thinking for everyone, for the sake of humanity. So we need this for energy and utilities, smarter infrastructure, for the power grids. We have, you may not remember because you're young, it was, I think, early 2000s, we have the electricity cuts in New York and the surrounding areas. And when you cut off the electricity for large scale cities such as New York, it is disastrous, okay? So you have to predict the demand. You have to have the backup systems in place, and you have to be able to manage them in a system that you see all the problems, and you need to be able to adapt to these problems very quickly, and which requires AI for sure, okay? And I want you to understand now, in this scenario, you understand the importance of cybersecurity as we are talking about this thing. Because if you don't have cybersecurity systems in the background, and this can be used for other different purposes. So every single thing that we do, we have to always keep in mind that all these systems will survive with cybersecurity. And the same thing goes for the clean water. You have to integrate with JS data, flow meters, pressure sensors, detection of the leaks. And many of the cities does this already, by the way. And including, I seen a project, for example, municipality of Ankara, which is the capital of Turkey. They did this maybe 5-6 years ago. They invested a lot of money for the digital twin of their water systems. So, but again, which is great, by the way, which is wonderful. But you have to think that this is not only one water system, but imagine that you capture the information for everything. And with the coming up with you understand the importance of carbon, and we know the energy is one of the most important things, and we are seeing this through the wars right now that we are suffering through Ukraine and Russia, etc. Hopefully, all these things are going to stop pretty soon. The energy is also very important. Using the energy the most optimized manner. and so that being self sufficient, so that you don't need any other countries, you can live peacefully, which all required that, creating digital twins of these systems, capturing the demand and managing these things properly. And of course, when you come to the airports and large facility management, HVAC and lighting adjustments is very important, because we are spending a lot of money, because these facilities are open 24 hours a day. So they are required a lot of requirements for the comfort levels. And many of these things, by the way, many of the airports that I've seen up to this point, they are managed with these either Samsung, or they are managed by Bosch, which is good, because you invested into these systems. At the end of you may pay, I'm just making up, $10 in the beginning, but they save you $10 a month every month. Incredible savings, because they provide, depending on the occupancy rates, they provide better environment, better lighting, etc. And all these things, the things that we teach you through the digital twin concepts, are going to be helping us through these large facilities from many different perspectives. And when you come to building, savings are there, incredible amount of savings, from energy consumption to the occupant satisfaction rates. And these numbers, I took it from sites so that I can share with you. But literally, you may not reach to 25%, but you will reach to some sort of savings in every building if you start using smart building concept, which I want you to go back, which starts from BIM. So you have to create the buildings three-dimensionally, which is an architectural process that is combined with the structural engineering, geotechnical engineering, mechanical engineering, electrical engineering, even landscape architecture. And when you carry these things into the city level using urban planners, then using civil engineers with the infrastructure, the savings are going to be much, 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 much more. And I want you to also mention again, the role of AI and machine learning is incredible in these things. And I tell many of my students, and I will tell you, you are lucky enough to take courses in this program in AI and machine learning. And many of the students doesn't have the chance. And I'll give you an example that, how the curriculums are changing. For example, in Istanbul Technical University, which is basically mandated by the government, that we have to teach one mandatory course to all the students, how to use AI and what is AI and how we can apply AI into our lives. And I want you to explain this, I think, I need to explain this a little bit to you. As civil engineers, structural engineers, architects, mechanical engineers, we don't necessarily understand the AI as good as a computer scientist or a computer engineer. But we need to understand how we can apply these algorithms into the studies that we are utilizing, which is very important. Because if we understand how we are going to apply these algorithms, there is a great value in the business that we are working on. And value is something very important to understand. What is value? The value is that we are basically producing the buildings that are more optimized for energy, that are more optimized for carbon, they're more optimized for comfort levels, they are more optimized for many different things from every single material. And not only that, one of the things that we learn through experience, construction process with the design process may take 2 years, but the buildings and infrastructure we produce goes much more beyond that. And many of the cases, these things we build will end up used for 60, 100 years. So when you have a building that will be there for the next 100 years, when you have a bridge that you build will be there probably many more 100 years, then you have to have different way of approaching into the design. And so AI in that perspective is incredible help. During construction and after the construction through the facilities, AI is going to be there to help us. And we need to understand as the engineers and the architects that whatever decision we make in the beginning is going to affect the structure for the next 100 years. and through the renovation of these structures, through the lifespan of these structures. So we have to look at the processes from the life cycle assessment perspective, not from the birth of the structure to the death of the structure. Through the every single stage, we have to be utilizing all these different technologies that AI is given to us, and which will help us tremendously throughout the life cycle of the building. And we have to always understand that digital twin and cybersecurity goes together. Without having proper infrastructure for cybersecurity, especially for the critical infrastructure, which is the survival of any country, especially during the disasters. Forget about the foreign threats. I mean, I forget about you that you are going to be in a war. Forget about that part. But imagine that during a huge disaster. Imagine that a huge fire hit Los Angeles. Imagine that when which failed tremendously in Los Angeles, by the way. The infrastructure, critical infrastructure, failed tremendously. They couldn't stop the fire because for many reasons. Imagine that your fire truck didn't have water. Do you think it's acceptable that your fire trucks doesn't have water and you are living in Los Angeles and you think that you are in one of the most advanced countries in the whole world, but the fire truck comes and there is no water in it? This is sad. This is sad that actually we let the politicians take away engineering thinking, because engineers will never let that happen. And engineers, civil engineers, mechanical engineers, electrical engineers, architects, we are good in saving people because as the civil engineering definition, we are here for the civilization. So that means that actually this is maybe what I think it's a good point to say. As civil engineers, we need to be in the politics also maybe, because as we start to learn that if you leave these politicians by themselves, they are making decisions that they shouldn't make. So we are learning that actually we talk about digital twin, cybersecurity, etc. I think we need to step in and start telling them, dude, you have to be careful because if there's a fire and there is no water, we have to put you in jail. But anyways, so this is important. Cybersecurity part of it also important. And I will tell you, we lived through this thing in Turkey. During the earthquake, you have to control the information and social media. And this is also AI, collecting all that information so that that actually there is a threat to change the people's way of thinking, which will basically disable you during the rescue processes. So therefore, I couldn't tell you how important it is to also invest into these things. And there are lots of challenges that we face. And one of the challenges is that all these systems, if you are going to create a smart city or smart infrastructure, has to talk to themselves. So we have to, even for BIM, we talk about industry foundation classes. We talk about creating a system that talks to each other. Even with BIM, we had such a big problem. But now we are talking about data from different sources. We are talking about the pictures, we are talking about the videos, we are talking about 3D laser scans, we are talking about maybe voices, sound, we are talking about text data which are coming from different formats, we are talking about documents from different formats, we are talking about all kinds of heterogeneous data that comes to us, and we are talking about taking them in and making smart decisions using this thing. It's which is a huge challenge for us, which requires lots of engineering thinking, putting things in perspective, creating proper algorithms so that these things are used for proper purposes, which is not an easy thing. I want you to understand that. So, but also you have to understand that there are some cities doing that. That's the reason I showed that list to you. That if you look at it, there are cities in this world that are manage this thing, they know what they are doing. But the challenge is how we are going to make sure that other cities in the whole world, that Istanbul does the same thing, Paris does the same thing, Bucharest does the same thing. So how we are going to make this Madrid have the similar system that talks to each other. And the best of the best, how we can create a data center that we can do it for the whole Europe, so that if something goes in Valencia, that people in Spain, people in France, people in Turkey has a way to contribute into that problem. So, but this comes with the high costs. and the rate of return for the investment is not going to be huge in the beginning. So that is also something we need to explain. So it's not going to be push a button type of thing. This is going to be a transformation, takes a lot of people changing their mindset and getting ready to this process. This is not even I cannot emphasize on it. Even the change from CAT to BIM took 20 years. Now we are talking about this much bigger change transformation, which requires different group of disciplines coming together, and which is not difficult. And I'm telling you, the link that I gave to you for the papers, you have to take a look at it. Even for us, we are trying to define what is really happening. But it is here. We need to make sure that we have to adapt AI and automation. We have to get ready for the metaverse and augmented reality integration for the simulation purposes. What I mean is, the street that in front of you, 20 years later, there will be more cars on it, hopefully, as the population is increasing, or for different purposes. If you can simulate these changes today, and if you can have an investment plan for the next 20 years, you will not face a problem 20 years later. And if you don't do these things today, then the cost of changing these things will be much more tremendous. Okay? So if we wait, as the United States did, 30 years before you invest into your infrastructure, then you have to invest $2, $3, $4 trillion to replace your infrastructure. And I have a news for you. They don't have the capability to do that. Because to be able to build $3 trillion worth of work, you need engineers, you need architects, you need mechanical engineers, you need all kinds of different people and contractors to be able to do this thing. You have to prepare yourself through digital twin concepts so that you can plan these changes properly, and you can also prioritize where you're going to invest through these processes. And I want to also mention and emphasize, none of these things goes with the climate adapted infrastructure, because sustainability is very important through these thinking. So now imagine that we need these super engineers, we need these super architects that can look things in a different perspective, which is not provided to them through their traditional curriculum. Because traditional curriculums are not designed to create super engineers or super architects. So I think this is a social responsibility to all of us, which this European Union funding provided to all of us, people in Spain, people in France, people in Hungary, people in Turkey, to have a different way of thinking, to educate new engineers and architects of the in the next 5 to 10 years. I didn't want to say future for that, because the need is here right this moment. And I want to also mention that robots are something that we didn't think that it's going to affect our lives, but that change and transformation happened very quickly. And the cost of the robots decreased incredibly. So now we have to also understand that we can include the robots into these systems that will make our lives a little bit much more livable. And this is for when you come to the construction side of it, it won't happen without you guys. So, and I want you to emphasize that Industry 5.0 revolution depends on human robot interaction. So this is another thing that we need to start focusing on. Not right this moment, right now for you, but as academicians, we're already focusing on this. Because, one of the pillars for us is the European Union, which provides us and tells us, you academicians and entrepreneurs, I want you to work on these things. And they tell us that actually, they tell us where the vision is going. And thanks to them, also, we have a chance to get funding to work on these things. And thanks to these fundings, people like yourselves are part of this system, that you are learning these new things. And, I want to make sure that we have to embrace the digital transformation. You cannot close your eyes. You have to embrace it. You have to invest into, as if you are coming from the municipalities or the governments, you have to invest into digital twin infrastructure. And you have to invest in AI and real-time data, because there is no way we are going to create smart and resilient structures without these things. And transformation is here right this moment. We have to be able to change these things, which is not going to be easy, ladies and gentlemen. And I just don't want to take too much time of yours. I just want to focus key takeaways. We need to make sure that we have digital twins enabled for real-time optimization. We have to really understand how AI and machine learning power our intelligent insights. We have to understand the importance of cybersecurity, not as an engineer for yourself, but you have to understand, you have to find the right group of people. And we have to understand that, cost savings and risk reductions are going to be there. We cannot close our eyes to this transformation. We cannot close our eyes to this revolution. And we have to make sure that we have to pave the way for autonomous, sustainable infrastructure. Because if we don't do this thing, it's going to be really difficult. I want you to, maybe I'm not using the right terminology, but I want you to understand that the way the governments think doesn't work. We learn that with the upcoming technologies. So we have to change that way of thinking so that we can reach these pathways. Thank you very much for listening to me. It seems like I already talked around 45 minutes, which was the time I promised. I am very happy to listen your questions, and if you want to add something to what I said. Thank you very much for your time.
Thank you very much, Onur, for this nice talk. So we have some time for some questions. So please go ahead if you have any. Yes, Pierre.
Yeah. First of all, thank you for your conference. Very interesting. I have some points I would like to talk to you about. I belong to the French Railways, and I have to imagine a digital twin for bridges. So you talked about bridges, and we have in France 32,000 bridges, railway bridges. So that's why it's a very huge number. We don't have the budget of the $1 trillion you spoke about, so we cannot replace them in one single year or one single decade. We have to deal with all those bridges. So we have to build. We would like to build the digital twin of existing bridges, and sometimes they were built 100 years ago, and maybe sometimes